So we're looking at climate change impacts and some projections that were tried, and I will make a couple of points on what happens when you actually downscale. So it's very important that we have a good sense of the global system, the projections, the RCPs, which are not local. Greenhouse gas concentrations are important at global scale, even though the sources and sinks are local, but the impacts are very much local and regional. So we looked at various states over India, and this is important because even within a state you have multiple ecosystems, different populations, different temperatures, rainfalls, humidities, diseases, movements of people, agriculture, and so on and so forth. So the most salient changes expected that were projected using a regional model for India basically projects warming all over. These are different scenarios, different model simulations, or different simulations of the same model. So what happens in these regional models is essentially the values at the boundary are prescribed from the global models. Either one or more models are chosen. So for example, different simulations from the same regional model may impose different global models at the boundaries. There's something to remember there when we do such a downscaling from global to local, is that the errors in the global model are going to impact the regional model because the values are being put in at the boundaries from the surface to the troposphere and above, and sometimes also in the ocean. But many of these models, they just prescribe the ocean temperature and they don't have an active ocean circulation. Why does it matter? Basically because when you look at projections of precipitation in 2030, for example, with respect to 1970, again different simulations of the same model that did the temperature, there is no reason to believe that these projections have better skill than the global model, other than that when you do a regional model, you use a resolution that is much higher. So the global model may have a resolution of, let's say, 200 kilometers longitude and 200 kilometers latitude, whereas a regional model like this typically would have something like, let's say, 30 kilometers or even less, maybe down to 10 kilometers. So there is some indication that the topographies like the Western Ghats, the Himalayas, and so on will be better resolved. So the rainfall projections and simulations along the topography or orography may be better resolved. But there is a syndrome called garbage in, garbage out, which means if the global model that is giving you the boundary conditions is completely wrong, then many of the errors will be influencing your regional projection. So that's something one has to be very careful about. So keeping that in mind, so the change in minimum temperatures are expected to increase much more than the changes in maximum temperatures. Already we are pretty warm. You cannot get much warmer because then you will begin to have wind changes, precipitation changes, and so on. So the changes in extreme precipitation events in the 2030s. So this is the intensity in the upper panel and the number of rainy days in the lower panel. In the monsoon lecture, I will show that a lot of things about the monsoon have been changing in the last 100 years. We have very good data to show this. So the projections of extremes again may not be highly reliable. So I'm just saying that because this is just one model whose simulations have been used over the UK and other places, but now India is doing a much better projection with its own Earth system model that I will mention at the end of the lecture. This again, you cannot see the scale, but basically this is the changes in yields of irrigated rice and rain-fed rice for different regions. We have been looking at Western Ghats, coasts, and the northeast. And wherever there are red, you know that the yield is expected to decrease. So without going into too much detail, the crop model or the yield model that was forced with the projections from this regional model. So it basically takes the temperature and precipitation from the regional model, which is downscaling the global models, and sometimes we compute yields based on some empirical relations between temperature, precipitation and yields, or sometimes we run what is actually a crop model, which gets quite complicated, but nonetheless such projections are made. How reliable they are, that has to be seen as well. This is showing the baselines and 2035 in terms of the changes in vegetation for the Himalayan region, northeast region, coastal region and western Ghats. Again, without taking the numbers too seriously, I just want to say that attempts were made to downscale particular scenarios called, for example, A1B, which was from the previous IPCC assessment. These are now being done much more reliably in the new model that I will again mention at the end. That's just to give you a sense that an attempt was made to make most region specific projections for India by one model. State-wise cumulative installations of solar photovoltaic cells. So from projections we are slowly trying to move into what are the kind of adaptation mitigation strategies that India is already adopting to deal with climate change, but also to deal to live up to its commitments to the Paris Climate Agreement. So by states and union territories here, things like solar lanterns, home lights, street lights, solar pumps, standalone solar power plants and power plants, solar power plants that have been connected to the grid and so on are given in terms of either kilowatt peak hours, kilowatt hours at peak, or thus the number of systems. The main point is that there is a substantial number of systems being installed. Already this is in 2012, this number has been going up. India is now probably third in terms of its solar installation after China and Germany, or close to being in the top 5. The state-wise breakup of energy parks and energy clubs as of December 31st, 2014, again by states and union territories, district levels, state levels and renewable energy clubs in terms of their numbers. Just to give you a sense that there is an attempt to make more of a bottom up community level efforts as well as top down incentives for solar lanterns, especially in rural villages and so on. Solar lanterns are essentially like batteries. If you charge it for a few hours during the day, it provides light for a few hours at night, which if you don't have electricity or if you're trying to save on electricity, it works very well. And there are many programs, including by NGOs, which have installed a large number of solar lamps all over the place. Source-wise and state-wise estimated potential for renewable energy in India in terms of megawatts as of beginning of December 2014. By state, looking at wind power, small hydropower, biomass power, cogeneration of gas waste to energy and estimated potentials, and these are the distributions. So the numbers are still kind of small in terms of the energy portfolio and what is the fraction of renewables, but to meet its goals of reducing the carbon intensity of the GDP by 25 to 30% by 2030 with respect to 2005, India has to essentially ramp up its renewable portfolio rather quickly, and there is lots of attempts happening on that front. Categorization of blocks, mandals and taluks for India for groundwater development. So remember again, as I said, something to remember, it's often referred to as FEW, food, energy, water nexus. So what is the competition between water for food, water for use for irrigation and human beings, and water for energy? And groundwater, as I will show a little bit later on, is being depleted in certain parts like the northwest India, which is the breadbasket, like Punjab and so on, where enormous amount of wheat is being grown, for example. Groundwater depletion rates are considered to be around 5 meters per day, and it is not being recharged at the same rate, which means groundwater is sinking. You probably have experience in your own neighborhood where a bore well now has to go several hundred feet deep to get water in most places, and it keeps increasing with time. So central western India, on the other hand, has some recharging going on, as can be seen from wells, regular wells where you can measure groundwater levels. But by state, groundwater developments are considered safe, semi-critical, critical, or overexploited. And you can see that, for example, Andhra Pradesh has 84 overexploited and 26 critical conditions for groundwater sources, and the total overexploited is around 802, which is 14% of the total groundwater, and critical is 169, which is about 3%. So you cannot do adaptation mitigation when you are, if you treat food, energy and water systems independently. You have to track them together. If government is giving subsidy to pump water, that energy is being used to groundwater mining to remove water for irrigation. Unless irrigation efficiency is improved, a lot of water will be lost. And there is some evidence that even when irrigation efficiency is improved, like with drip irrigation, the automatic tendency is to increase the amount of land that's being irrigated and end up withdrawing more water. And there is very good data for states like Rajasthan, where lots of water revolution happened, where drip irrigation and other efficient irrigation methods came in, farm incomes went up, but water withdrawal also has gone up because people are now just irrigating more land. So government has to incentivize to essentially track more food production with less water use, and not just focus on irrigation efficiency, because that doesn't say how much water is being withdrawn. Those are part of the mitigation and adaptation strategies that every country has to worry about, but mostly countries like India, which are hot tropical countries, rely on rainfall for all of its water, and rainfall is becoming more problematic, as we will see in the monsoon lecture. This is state-wise area in hectares under organic farming, as registered under accredited certification bodies. Again, by states, certified cultivated organic areas, in conversion of cultivated areas, and total cultivated areas that are under certification processes, and wild areas. So organic farming, again, like irrigation efficiency, is supposed to reduce, for example, water contamination by using methods that are good for soil, as well as use of fertilizers and use of water. So essentially, the whole system of agriculture is supposed to become more sustainable, as well as externalities like air quality, water quality, food quality and food security are supposed to become better under these kind of plans. So again, good news, there's lots of efforts in this direction, and even some small towns in many states now have organic markets on weekends and so on, that you may know of in your own neighborhood. Biofertilizer production, again, to go with the organic farming, biofertilizers are less harmful as chemicals. They could include garlic, neem and other products which are natural, so they contaminate the groundwater less, and they keep the soil health better than massive industrial fertilizers which use nitrate, phosphate and so on. So it also tends to reduce the application of fertilizers. So again, actual production of fertilizers in metric tons from 2008 and 9 to 2012-13, you can see in most states it went up from here, Andhra 168 to 1335, so almost 10 times. There are some downward trends. I think Jharkhand, we have to figure out what this number means, seems to have gone from 11,921 let's make sure of the units, which is not here, but we should look it up, down to 3530. So maybe it's the splitting of the state or some other factor may be involved, but most other states numbers have gone up, some substantially and some not so substantially, and the total obviously has gone up almost 60-70%. So biofertilizer is a useful thing, but like biofuels, the competition for food has to be looked at, because every time there is a good thing, if it raises food prices or reduces access to food for some groups, then that has to be also considered in the overall health of the system that you are trying to manage. Drought tolerant varieties of field crops. So if you make a field trip to your local agricultural university, all of them have some research going on improving the varieties either for drought resistance or heat resistance, both of which are critical with global warming, especially if you are in semi-arid areas, which is much of central India and peninsular India, where rainfalls are quite moderate and very seasonal. So you can see there is rice varieties, wheat, maize, sorghum, pearl millet, barley, pulses, oil seeds, and commercial crops like cotton and sugarcane, and other varieties and hybrids like jute and so on. So these are the various zones where the various traits are being tried, which again is an investment by the government in agricultural research, crop research, as an adaptation and mitigation to changing climate. So that should synergize with the investment in monsoon forecasting and satellites to look at crops and vegetation and land use change, and so on and so forth. Statewise release under centrally sponsored schemes for protection of the environment in crores of rupees. There are many programs since 1980, for example, they have been tracking the diversion of forest land to other use, and it's banned in many areas. There are many areas where protected tigers, elephants, and lion forests, and so on and so forth, black bucks, etc. So this involves conservation of management of mangroves and coral reefs, very critical. You can see that the allotted funding is not always going up. Many of them have gone down. Wetlands, biosphere reserve schemes, biodiversity, lake conservation plans, Green India Mission had a spike of funding in 2012, but somehow we have to figure out what happened to it. Integrated wildlife habitats. So this is about how to do development without fractioning the habitats. Project Elephants, Tiger, forest management. So in the 2018 floods of Western Ghats and Kerala and Karnataka, you are reading that in fact the Comptroller of Auditor General had written a report in 2017 about plans for dams for emergency operations when there is a lot of rainfall. There are older reports on how the ecology of Western Ghats is being reduced because of human activities and so on. So those impacts are now being blamed for making the floods much worse, right? So the rains are important for creating floods, but how much flood happens depends on how the slopes have been reduced in forest cover, because that makes a runoff much worse, including bringing a lot of mud into the cities and so on. So there are lots of national awareness campaigns as well, which I'm sure you can use as a part of the teaching if there is something in your neighborhood or you want to start something. This is the National Afforestation Program, where forest cover is being increased, going from 2000 to 14 and 15. And there are many places where India has made tremendous progress in growing forest cover. So in the global map, India shows up as one of the places where actually forest vegetation, forest cover has grown. There are details. If you look at satellite maps, it just shows how much green there is. It doesn't say how thick the forest is. You can actually have trees that look like increased forest cover, but the forest density can be reduced, which cannot easily be seen from a satellite. So That relates again to how the water is being recycled in the forest, how much runoff happens, how much carbon is actually being sequestered, and so on. So you will probably have a lecture on climate change impacts on vegetation, where some of these issues will be looked at. So these are all the states where afforestation has happened over these 15 years, and you can see overall the forest cover has gone up quite a bit, which is good news on a national scale, which is consistent with the India's plans of increasing the carbon sink by 2 to 3 gigatons in the coming decades, which forest is one of the most important ways to do that. State-wise details of protected area network. This is the national parks, wildlife sanctuaries, conservation reserves, and other community reserves. Again, various numbers from each state. Just shows you the details at which all these things are being looked at as part of the overall adaptation mitigation strategy. Along with that, you have to track air quality and water quality. So there is a tracking of various pollutants like sulfur dioxide, nitrogen oxide, PM or particulate matter. As I said, one of the worst health impacts on respiratory disease, especially for kids and older people, especially PM 2.5, which is 2.5 microns, which you cannot even see and you breathe it. It's very dangerous. Ozone comes from inefficient burning of fuels in vehicles. So again, stratospheric ozone is good because it removes UV, which is bad for us. Tropospheric ozone is a greenhouse gas, and it's a very nasty negative health impactor. Lead, there is still a lot of lead in the system, even though a lot of fuels have been switched to unleaded. Carbon monoxide, ammonia, benzene, and so on and so forth. So the time weighted averages are attributed to industrial, residential, rural, and other areas, and ecologically sensitive areas with various methods of measurement. So if you drive around in Pune on Pashan Road, the Indian Institute of Tropical Meteorology has a big digital board that shows air quality in Pune. They have similar boards in other cities like Bombay and Delhi and Rajasthan, Jaipur, and so on and so forth. Okay, so lots of efforts going on. The step that remains is now to connect those air quality standards to hospitalization because of health impacts and so on and so forth, which will happen in the coming years. Again, along with air quality, you have to also track water quality, which is being done with drinking water, outdoor breathing, source and treatment and disinfection, propagation of wildlife and fisheries, which is affected by water quality, irrigation, industrial cooling, controlled waste disposal. So these are always some things to keep track of. So these are coliforms, pH, dissolved oxygen, biogeochemical oxygen demand, and for each sector they are being tracked. There are rules and regulations in the book. How strictly they are enforced obviously has to be looked at, but you can look at it in your own neighborhood as well. Exhaust emission standards, again one of the most critical things for India, considering the number of vehicles is growing almost exponentially overall, and especially in some big cities. So you can see that the emission norms for passenger cars, for example, in 1991 and 1992, carbon monoxide and hydrocarbons and NOx. NOx are basically all kinds of nitrous oxides that are emitted by vehicles. You can see it went from 14.3 to 27.1 down to 4.34 to 6.2, and HC and NOx went from 2 down to 1.5 to 2.18 and so on. So these are directly related to health as well as to climate change. So part of the mitigation adaptation is also to reduce the greenhouse gases from fossil fuel burning, and emissions norms are part of the critical. There are similar changes for heavy duty and light duty vehicles, and also 2 and 3 wheelers, which are huge in India, and they contribute significantly. So before I come to take home messages, I want to mention the newer efforts that have been happening in India. So IMD, the India Meteorological Department, which is under the Ministry of Earth Sciences, has for the longest time been the keeper of collecting all the temperature, meteorological data, forest data, humidity, rainfall, and so on. And they have been issuing forecasts of monsoons and some efforts at weather forecasting for a long time. But starting about, I don't know, let's say 2005 or 6, massive funds were put into improving both weather forecast, which is a few days, and what is called extended range forecast, which will become clearer when we look at the monsoons. Essentially, that is beyond 1 week out to few weeks, and climate forecast, which is 1, 2, 3 seasons. So in May, you will say what the monsoon will be like. That is a seasonal outlook or seasonal forecast. Each day you will get forecast for the next few days, which includes temperature, winds, sometimes air quality, and so on. And extended range is useful for farmers who want to know if it's going to rain next week or not, because they have to plan their irrigation, sometimes sowing, harvesting, etc., or protect some crops if there is storms coming, etc. So the modeling effort has included a full Earth system model, which obviously has an atmospheric component, an ocean component. It has sea ice, ocean biogeochemistry, all kinds of land, surface, and hydrology, and ice sheets, terrestrial vegetation, and the ocean biogeochemistry basically includes nutrients like nitrate, nitrite, iron, silica. These are advected, circulated, mixed, upwelled. Then they, depending on the availability of nutrients and light, they produce phytoplankton photosynthesis, which is the primary production, which can then be used to look at a fish production and so on, either using a fish model or sometimes just directly using relations between primary production and fish. We didn't say exactly what primary production is, but basically often referred to as PP is the amount of carbon that is converted from inorganic into organic. So if you remember, let me maybe write that here. It's a very simple relation. When you have water and CO2, you have to take 6 of each. Then you produce C6H12O6 plus. Photosynthesis produces what? Oxygen, right? So plus 6O2. So this is the carbohydrate or sugar molecule that is produced by photosynthesis. So primary production is essentially a measure of how much inorganic carbon, like carbon dioxide, is converted to organic carbon. There are various ways of measuring it. We looked at the satellite map of ocean chlorophyll, which is an indicator of how much primary production is happening. The same satellite also measures the chlorophyll on land, so you can look at the global biosphere and so on. So the models do that in the ocean as well as on land. So the vegetation interacts with the soil, cycling of nutrients, carbon dioxide, water, how the storage of water, rainfall flowing through the system is affected, and so on. So essentially what we earlier on called as the Earth system model. So if you want to get into the business of buzzwords, and you can call them ESMs, Earth system models. So if you know what ESM is, you can go to IITM and ask them to show you their ESM. So it's a model that they got from the US, and then they have employed a lot of people to work on it as an ocean model, a land model. So this model is doing the extended range forecast and the climate forecast. There is another model that is being used by another part of the IMD and MOES called NCMR WF, which is the National Center for Medium Range Weather Forecasting. I don't think we need to worry about all these terminologies, but nonetheless, all these are dynamic efforts as opposed to before, where only statistical methods were being used to make forecasts. Now these are actually solving the Earth system model to do it. They are more accurate because as the relation between El Nino and monsoon changes and so on, these models automatically can keep track of all the changes that are happening, including increasing greenhouse gases and their impact on temperature, humidity, rainfall, vegetation, and so on, ocean circulation, winds. So the same model is being used for making projections. So when AR6 comes out, we will have for the first time a contribution from India, which will run all the RCPs and some SSPs, the shared socioeconomic pathways, and there will be many results being published in the years starting essentially now, this in 2018 into 2019, 2020, so that by 2021 Indian model will be compared with all the other models from the world. So I kind of tried to be a bit dismissive about the previous efforts of climate projections with the regional model, because that model was run without an ocean, without a sophisticated land, without all this biogeochemistry, and without sophisticated hydrology and so on. So I said that was one effort. It's good to show that we did it, but this is much more comprehensive. This will be assessed along with all the other global centers from US, UK, France, Germany, Australia, Norway, China, and so on. So it will be a stringent test on how well we are doing the projections. So this, since it's being run from India, much more attention will be paid to what these projections are doing over India. That's always important. Maybe they will be further downscaled using a regional model, but that's a separate issue that we won't discuss. So these kind of ESM models also will begin to explore what I have been already mentioning a few times, food, energy, water nexus. My own favorite thing is also to always include health in it, because food affects health, water affects health, energy production affects pollution and health, and water quality and health. So this is kind of a schematic that comes out of the World Meteorological Organization and the UNFCCC, which looks at the goals and interests of different social, economic, and environmental goals and interests that are related to water, energy, and food. And obviously, they all interact through what are generally referred to as stakeholders, or people who are interested in having access to them, buying them, selling them. So it includes industries, farmers, individuals, governments, import-export companies, agricultural companies, GMO companies, and so on and so forth. So the scenario development wants to look at the managing the relation between them, local scale, global scale, and so on, because when you grow food in one place and export it, there is also an aspect of water associated with it, energy associated with it, and vice versa when you import from somewhere else. Evidence being collected for how the connections are working and what are the response options when you compare things like what are called drivers. So population growth, urbanization, diversifying and changing diets with economy growing, proteins more from fish and meat, for example, cultural and social beliefs and behaviors. For example, countries like India, Thailand, Japan, you cannot get people to stop eating rice even if incidence of diabetes goes up tremendously, because culturally we are used to eating rice. Rice is hyperglycemic, which means it's not good for diabetes, but those kind of social and cultural beliefs, it could be consumption of meat or fishing or killing whales for food and so on, and of course climate change. On this side you have governance issues, sectoral policies, and vested interests. So what are the GMO companies trying to pass as regulation, international and regional trade and markets and prices. There are companies which are experts in what are called weather derivatives and climate derivatives. So they look at forecasts and they try to bet on commodity prices, how they will go up and down, and they make money on it. So those kinds of trades and markets. Industrial development, always in interaction with water demand, energy demand, and impact on food. Agricultural transformations, lots of research now going from genetics all the way to crops and how the uptake of nutrients by crops is changing. So with warming, it turns out that crops may grow, but they are taking up less so-called micronutrients, which are minerals and vitamins, iron and zinc and other things that we need. So those kinds of things have to be considered. And of course, technology and innovation, where there are things like smart agriculture, where you are looking at the humidity level, you're looking at the soil moisture level, your tractor has a satellite receiver which tells you when the rain is coming, when cloudiness is coming, how much fertilizer to apply, and so on. So smart agriculture is becoming a big thing. So the resource base for managing this nexus is of course the land, water, energy, capital and labor. So this is a complicated system. This is often called as systems approach. So you don't try to manage just water, saying how much water demand there is, how much rain there is, how much reservoir there is, water treatment, etc. You don't look at just energy, saying how much energy demand there is and how much it's increasing, and just food. You just try to combine all of them together. This is complicated, but now it's definitely moving in a more so-called systems approach. So we wanted to look at India impacts just to get a sense of what are the kinds of data that are being gathered, what are the kinds of mitigation adaptation measures that are being considered, what are the kind of models that are being developed, what are the plans for reducing carbon footprint into the future to keep up with the Paris Climate Agreement and so on. So it's more of an introduction, because this lecture in a few years, when all the AR6 projections are put out by India, is going to look very different, because there will be much more details on projections of various rainfalls, extremes, food production, vegetation and so on for India, including coastal oceans, fisheries, acidification and so on. So definitely this lecture will be updated in the coming years. So India is obviously experiencing a very clear sign of global warming. Temperature increase is very obvious. The monsoon lecture, which will start next, will show that the response of the monsoon to global warming is quite complicated. It's already being obvious. I will show a map of how the rainfall distribution is for this year. Impacts are seen on food, water, energy and health and their interactions, and baselines and data to monitor the changes are seriously lacking. So if we look at all the tables, you think, wow, we have so much data, but actually when you say Andhra Pradesh has this kind of temperature, this kind of rain, it loses a lot of the granularity. Andhra Pradesh, now split into Telangana and Andhra, has a wide range of climates, same for Maharashtra or Karnataka or any other state, right. So if you go from South Karnataka to North Karnataka, the climate changes quite dramatically. If you go from coast to inland, for example Maharashtra, even inland from Pune to Marathwada and Vidarbha, it changes quite a bit. So we need tremendous amount of data at those scales in your neighborhood, literally. So this is where maybe your climate education can become much more complete by crowdsourcing the data gathering in your own neighborhood for, of course, temperature and precipitation and humidity and winds and so on, but also for biodiversity, water quality, air quality, etc. There are many programs which will allow you to use funding and do it. So you should follow up definitely, so that locally you can track the changes. If you collect data for 10 years, you will begin to see what changes are happening. Modeling activities have taken giant steps and projections will improve in the coming years. We have to initiate as many efforts as possible for crowdsourcing data gathering. If there are 500 million cell phones in India, that is more than the number of toilets apparently. Maybe it's changing, hopefully it's changing because of all these new initiatives on 2 Gaddawala and so on. But imagine having measurements of temperature and humidity and maybe other things, indoor air quality, which is already being done. Okay? So, you can motivate your kids to think about those kinds of solutions. The opportunity is huge. The mobile platform is now so ubiquitous, it will be connected with the Internet of Things to everything. So, you can tell your students that they don't have to be climate scientists, but they can be engineers, make money and work on green technologies and climate solutions. And you have to log as many changes as possible. So, everybody has a cell phone, so just clicking photographs of vegetation, insects, butterflies, birds, sounds, and there are many agricultural universities where you can actually send an image of a plant and they will tell you which species it is and so on and so forth. So, you have to generate this curiosity among the kids that environment around them is something that has to be observed very keenly because that is their future. So, we will stop this lecture here and come back and try to wrap up the Indian monsoon story, which is also one specific aspect of climate change and climate change impacts over India. See you next time.